Alright, so this video is going to be part one where we're going to show you how to do the Measuring Gravity Lab. So in my chapter 2 packet I've got the Measuring Gravity Lab, and I really hesitate to go through this with you because really you need, in order to learn how to do physics, you need to do physics on your own, and you actually have to put your hands on it, and you have to do it, and you have to measure it, and you have to figure it out. And so it's really no good for a teacher to just show you. You've got to do it yourself. That said, I'm making a video so that people in my class who can't attend class can see what's going on, and so that people around the world can just get an idea of how to do physics. Alright, so what do I have here? I've got a ramp, I've got a cart to roll along the ramp, I've got some masses that are going to go on the cart. For the second part, this brick is just going to be a spacer to hold the ramp up. I've got my measuring tools. My measuring tools is my go-to-all meter stick and my stopwatch. So what I am going to do is I'm going to measure 1 meter along the incline. So right there, now what I'm going to do is I'm going to set my brick so that it is 1 meter along the incline. And I'm going to move it over to the other side to make sure I'm square. I'm more or less happy with that. Now, what I'm going to do is I'm going to measure the time it takes for the cart to roll 1 meter down the incline. Okay, so I've got my cart, and I'm going to line it up as best as I can by eye, and I'm going to go 3, 2, 1. Okay, 3, 2, 1, go. Didn't go. 3, 2, 1, go. Now let's do it again. And this is one of the things that if you do it yourself, you know that you've got to work through. 3, 2, 1, go. 2.09 seconds. Now I can't just leave it at that. I got to do it a few times. So let's do it a few times. That was 2.09 seconds. Then we got to go 3, 2, 1, go. I went a little bit earlier in there. I got 1.91 seconds. But we'll do like 6 of these. 3, 2, 1, go. 2.06 seconds. 3, 2, 1, go. 2.09 seconds. 3, 2, 1, go. 2.03 seconds. One more time. 3, 2, 1, go. 2.03 seconds. Now I know that I went early on that 1.91 seconds, so I am going to cut that one out of my data set. Now, the next thing that I want to know is, and I want you guys to think about, this is what I want you to think about. The cart by itself weighs about 250 grams. I just added 500 grams of mass onto this. So now this cart is 3 times heavier than it was before. So the cart is 3 times heavier, and I want to know, hit pause and think about what effect tripling the mass is going to have on the acceleration and how long it takes to roll down. Is it going to take more time or less time to roll down the ramp? Hit pause and think about it. Okay, we're back, and we are going to do the experiment. So once again, here we are. 3, 2, 1, go. No, it didn't go. Sorry. 3, 2, 1, go. 2.00 seconds. Do it again. 3, 2, 1, go. 2.09 seconds. 3, 2, 1, go. 2.07 seconds. 3, 2, 1, go. 2.04 seconds. And one more time. 3, 2, 1, go. 2.03 seconds. Okay, hit pause and think about that for a second. Okay, now Galileo said that all objects accelerate towards the Earth at the same rate. This is the exact same thing. Whether we have a heavier object or a lighter object, it shouldn't matter. And what we just determined is that it doesn't matter. Okay, so now in the lab you can do this for a couple more angles, do it for an angle like that, do it for an angle like that. The last thing that I want to know was I want to know how far up I jacked my ramp here. So I have to measure how wide this brick is. So I measured this brick to be 5 centimeters wide. So that means that when we go back and we do our little calculation in the next video, we're going to have a triangle that has a hypotenuse of 1 meter and has an opposite of 5 centimeters. Okay, that's that.